Alright, good day viewers. Today we'll be looking at machines on physics. A machine is any device or tool by means of which a force or effort, E, applied at one point can be used to overcome a force or load, L, at some other point. So on the application of effort, load is being overcome. On the application of effort, load is overcome at some other point. Now it says a machine enables us to do work more easily and conveniently than could be done without it. For example, it is easier to roll a drum of oil up an inclined plane onto a lorry than to raise it up vertically without the inclined plane. So that's the essence of a machine, to make the work done more conveniently, easier and faster. Alright? Now, they say the following terms and formula are common to all types of machine. The first one is the mechanical advantage. Mechanical advantage. Mechanical advantage is also known as force ratio. It's also known as force ratio. That is MR is the same thing as FR, and it is equal to load over effort. Okay, so that's the formula for mechanical advantage, is load over effort. That is MA, that is mechanical advantage, is equals to load over effort. So we'll be making use of this formula in solving the mechanical advantage of a machine. The mechanical advantage of a machine is its load divided by what? Effort. So take note of this. Okay, so mechanical advantage is also known as the output force over the input force. Okay, but its basic formula is load over effort. Its basic formula is load over effort. That is the basic formula of mechanical advantage, is the load divided by the effort. Alright, take note. It's also known as force ratio. Alright, the second thing we'll consider is velocity ratio. The velocity ratio of a machine. The velocity ratio of a machine is equals to distance moved by effort over distance moved by load. Okay, so it is the distance moved by effort over distance moved by load. Okay, mathematically it is VRA is equals to small e over L. Okay, distance moved by effort over distance moved by load. That's the formula for velocity ratio. Alright, while that of mechanical advantage is the output force over input force. Basically it is mechanical advantage is load over effort. That is this, load over effort. Okay, then the velocity ratio is distance moved by effort over distance moved by load, which is this formula, E over L. Okay, also the velocity ratio is equals to distance between effort and fulcrum. Distance between effort and fulcrum. The fulcrum is the balance point or the pivot, okay, of a system in equilibrium. This is the balance point, the fulcrum. So distance between the effort and fulcrum over distance between load and fulcrum. Okay, so it is distance between effort and fulcrum over distance between load and fulcrum. Okay, also we should know that the reciprocal of velocity ratio will be equals to the reciprocal of E over L. That means that the reciprocal of velocity ratio is equals to L over E. That is when I take the multiplicative inverse of this, I'll have this. So mathematically, the reciprocal of velocity ratio is equals to distance moved by load over distance moved by effort. Okay, so that is the reciprocal of velocity ratio. Velocity ratio is distance moved by effort over distance moved by load. Now its reciprocal, now taking the multiplicative inverse, we're having L over E. That's distance moved by load over distance moved by effort. Okay, so we have taken note of that. The velocity ratio is distance moved by effort over distance moved by load, while its reciprocal is L over E. And also we have also stated that the mechanical advantage of a machine is load over effort. Load over effort. Please take note of that. Now let's look at the next one. The next one there, the next formula is okay. Now the next formula there is efficiency. Efficiency is equals to work output over work input times 100 in percentage. Okay, efficiency is work output over work input times 100 in percentage. Now we know that work is equal to force times distance. Okay, work is force times distance. Now this force will be in two phases. Both the phases are load and effort. So the work output now, work output will be equals to load times the distance here. The force here is the load, while the distance is distance moved by load. Distance moved by load. Okay, while the work input, this force will be effort. Effort, and the distance will be moved by effort times distance moved by effort. Okay, so that is the work input is effort times distance moved by effort. The work output is load times distance moved by load. Now if I fix them into this formula now, I'll be having that efficiency of a machine is equal to, in place of this work output, I'll be having load times distance moved by load over, in place of this work input, I have effort times distance moved by effort multiplied by 100. Okay, that is multiplied by that 100 there. Okay, now the symbol for efficiency is this. It's a stylish E. Some textbooks write it like this. Okay, why some take it like this. Okay, so we can take this as efficiency. Efficiency is equals to, the load now is capital L, distance moved by load is small l, the effort is capital E, times distance moved by effort is small e, multiplied by 100. And if I split them, I'll be having efficiency is equals to load over effort times distance moved by load over distance moved by effort multiplied by 100. Okay, that's what we're having. Okay, this is what we're having. Efficiency now is load over effort times distance moved by load over distance moved by effort times 100. Okay, but recall that mechanical advantage is load over effort. Also recall that the reciprocal of velocity ratio is equals to distance moved by load over distance moved by effort. Okay, now that means that the formula for efficiency will change. This formula now will change. In place of this, I'll write mechanical advantage In place of it, I'll write the reciprocal velocity ratio. So that means the efficiency now, efficiency will be equals to mechanical advantage, that is in place of this load over effort, in place of this I'll write mechanical advantage times, in place of L over E, I'll write the reciprocal velocity ratio multiplied by 100. Okay, so MA times 1 will give me MA. That implies that my efficiency is MA divided by VRO multiplied by 100. Okay, this is the efficiency of a machine, and it is measured in a percentage. Okay, so the efficiency of a machine is the mechanical advantage divided by the velocity ratio multiplied by 100 measured in percentage. Okay, this is the efficiency of a machine. So we'll make use of this formula. And one other formula we also stated was efficiency is work output or work input times 100%. So we'll make use of these two. Okay, all right. These are the derivatives, and then finally we arrived at this. Okay, efficiency is also equal to useful work done by machine over useful work put into the machine useful work put into the machine multiplied by 100 measured in percentage. Okay, so it is useful work done by the machine divided by the useful work put into the machine times 100 measured in percentage. So that is efficiency. It is the useful work done by machine over useful work put into machine times 100. Now this useful work done by machine is also similar to the work output, and the useful work put into machine is also similar to the work input. Okay, so it's either use any of these three formulas. The first formula was work output over work input times 100 measured in percentage. The second one is efficiency is mechanical advantage over velocity ratio times 100 measured in percentage. And the third one is efficiency is useful work done by machine over useful work put into machine times 100 in percentage. All right. Okay. Where the stylish E is equals to efficiency measured in percentage, and then MA is equals to mechanical advantage okay, it has no SI units. Then VR is equals to velocity ratio. Velocity ratio also does not have an SI unit. Then L is equals to load measured in newtons. Okay, all right. Then E, capital E, is the effort measured in newtons. Then small letter E is distance moved by effort measured in meters. And small letter L is distance moved by load. Distance moved by load measured in meters. Okay. Alright. And the F arrow is force ratio. Also note that mechanical advantage is similar to force ratio. Take note of that. Very important. Okay, so those are the meaning of all the parameters I've explained all the parameters, the E, small el, and the FR. I've also explained that of efficiency, MA, VRO, and the L, capital L. Alright, we have a question on the board. It says a machine has an efficiency of 80%. If the machine is required to overcome a load of 60 Newton with a force of 40 Newton, calculate its velocity ratio. Alright, so quickly let's solve that. First, we'll list out the parameters given to us. The machine has an efficiency of 80%. The efficiency of the machine, the efficiency of that machine is equals to 80%. Okay, if the machine is required to overcome a load of 60 Newton, the load which must be overcome is 60 Newton with a force of 40 Newton. Now, this force that overcomes the load is an effort. The force that overcomes the load is an effort. So we say effort E is equals to 40 Newton. We are asked to calculate its velocity ratio. So the velocity ratio of the machine is unknown. Okay, the velocity ratio is unknown. So I can then look for the mechanical advantage. Mechanical advantage is equals to load over effort. It's load over effort, which will give us the load is 60 divided by the effort is 40. So this will cancel, and then I'll be having 2 here is 2. 2 into 6 is 3. That is 3 over 2. Okay, so the mechanical advantage MA will be equals to 1.5. Okay, that's 3 over 2 or 1.5. Now I can then look for the velocity ratio. We know that efficiency is equals to mechanical advantage divided by the velocity ratio multiplied by 100. Okay, so we are given an efficiency of 80%. We're given an efficiency of 80%. Now, if I convert this percentage to fraction now, and using that formula, in place of E now, I'll put my 80% there, which will be 80 over 100. Okay, so that will be, this now will be 80 over 100 is equal to, the mechanical advantage was 1.5. 1.5 over velocity ratio is unknown. Okay, so if I then cross multiply, that is 80 times VRO equals to 100 times 1.5. Okay, that's when I cross multiply. So if I divide by the coefficient of velocity ratio, I have the velocity ratio is equals to 100 multiplied by 1.5 divided by 80. Okay, that will give me, this will cancel this. So I'm having a velocity ratio is equal to 10 times 1.5 is 15 divided by 8. That will be, to give me, so this will give me 1.875. Okay, so I can approximate it to say, therefore my velocity ratio is approximately 1.88 to 2 decimal places. Okay, and then I approximate 5 to 7. So velocity ratio is 1.88. Okay, right, that is it. That's the solution to that question. Alright, that's the solution to that problem. Okay, we can then move over to the next question. Let's move over to the next question. Alright, we have another question on the board. It says the efficiency of a machine is 80%. Determine the work done by a person using this machine to raise a load of 200 kg through a vertical distance of 3 meters. So we have to determine the work done by a person using this machine to raise a load of 200 kg through a vertical distance of 3 meters. That is 3.0 meters. And we are told to take acceleration due to gravity as 10 meters per second square. Now let's list out the parameters in that question. First, we'll look at the efficiency of that machine, which is 80%. So we say efficiency of the machine was given as 80%. percent. Okay, it says determine the work done by the person using this machine to raise a load of 200 kilograms through a vertical distance of 3 meters. So we look at the load. The load L is 200 kg. We'll convert it to newtons. Convert it to newtons. That is, we are stating that the load is similar to the weight of an object, which is mass times acceleration due to gravity. Okay, so that means that the load now will be equals to the mass of the block is 200 kilogram multiplied by acceleration due to gravity is given as 10 meters per second square. That's G was given as 10 meters per second square. Take G as 10 meters per second square. Okay, so in place of this G now I write what? 10 meters per second square. So 200 times 10 will give me 2000. That's my load is 2000 newtons. Alright, now I'll continue. Now it goes on to say it is raised through a vertical distance of 3 meters. Through a vertical distance of 3 meters. Okay, that's the distance moved by the load is 3 meters. So distance moved by load small l is equals to 3 meters. That's 3.0 meters. Okay, the distance moved by load is this, and the load itself is 2000 newtons. Alright, now they said we should determine the work done by a person using this machine. So the work done by a person using the machine is equivalent to the work put into the machine. Now remember the third formula I gave you for efficiency. The formula is efficiency is equals to work done by machine divided by the work put into machine. The work put into the machine multiplied by 100 measured in percentage. Okay, and the work put into the machine is the work done by the person. That's what we asked to find. Okay, now work done by machine is load times distance moved by load. Okay, divided by the work put into the machine. Work put into the machine times 100. So it implies that my efficiency now will be equals to L times small l over work put into machine times 100. Okay, now I can put the value for efficiency. Efficiency was given to us as 80%. That is 80 over 100 is equals to the load is 2000 newtons. That's 2000 times distance moved by load is 3 meters. Distance moved by load is 3 meters. That's 3 over work put into machine. Work put into machine. Okay, so there will be no need for this 100 because it has come here as the denominator. Alright, when we converted 80% to fraction, so we had this 80 over 100 equals to 2000 times 3. Now 2000 times 3 will give me 6000. So this is 80 over 100 will be equal to 2000 times 3 is 6000 divided by the work put into machine. Okay, and when I multiply this with this, I have this 6000. Now I can then cross multiply. So if I cross multiply, this will multiply this, and this one 100 multiply 6000. And I'll be having 80 times work put into machine is equals to 6,000 times 100. Okay, so that means that the work put into machine will be equals to 6,000 multiplied by 100 divided by 80. That's, I'll divide by the coefficient. The coefficient of this work put into the machine is 80. So that if I make this subject of formula now, I'll have something like this. Okay, that is it. Now what happens? 0 will eliminate 0, and then I'll be having this times this is 60,000 divided by 8, and that will give me, so when I divide this now, I'll be having 7,500 newtons. Joules. Work is measured in joules. Okay, that is the work put into machine. So let's go back again to the question. We were asked to find, it said, determine the work done by a person using this machine. And you can recall when I was stating the parameters, I stated that the work done by a person using the machine is equals to the work put into the machine. Alright? They say therefore, work done by a person using the machine is equal to 7,500 joules. Alright. Okay, so we made use of the formula which helps us to obtain the efficiency of a machine. I think that was the third formula. Efficiency is equals to the work done by machine divided by the work put into machine times 100 in percentage. Finally, we have gotten this. The work done by the person using the machine is 7,500 joules. Okay. Alright, we have another question on the board. It says the velocity ratio of a machine is 5 and its efficiency is 75%. What effort would be needed to lift a load of 150 Newton with this machine or with the machine? Options are 50 Newton, B 40 Newton, C 30 Newton, and D 20 Newton. So let's look at the first statement. The velocity ratio of the machine is 5. Velocity ratio VR is equals to 5, and its efficiency is 75%. So efficiency is equals to 75%. Alright. What effort would be needed to lift a load of 150 Newton? The load is equals to 150 Newton, and then the effort is unknown. The effort E is not given to us. That's what they say we should find. Okay. Now, so let's solve that quickly. We know that the formula for efficiency is mechanical advantage over velocity ratio times 100 measured in percentage. Okay, efficiency is mechanical advantage over velocity ratio times 100. So we'll put the value of the efficiency there, 75%, converting to fraction is 75 over 100. So that will be, this now give me, this will be 75 over 100 is equal to, the mechanical advantage is unknown, divided by the velocity ratio was given to us as 5. Okay, so I can cross multiply. This will multiply this, and this will multiply this. So that is 100 times mechanical advantage is equals to 5 times 75. That's when I cross multiply. If I make MA subject of formula, how that my mechanical advantage is equals to 5 times 75 divided by 100. Okay, so I'll make MA the subject of formula. Now I'll divide by the coefficient, which is 100. So 5 go here, 1. 5 into 100 will give me 20. Okay, so I have my mechanical advantage now will be equals to 75 divided by 20. That will be 5 can go, you have 4. 5 going to 7. 5 going to 7 is 1, remainder 2. 5 into 25 is 5. Okay, so that will be 5. So my mechanical advantage is equals to 15 over 4. Okay, now we say recall that MA is equals to load over effort. Okay, And that means I can make effort subject of formula. If I interchange position, effort will be equals to load over mechanical advantage. That's when I interchange their positions. That means that the load was given to us as 150 Newton divided by mechanical advantage is 15 over 4. So this is equals to 150 divided by 15 over 4. That's this line is symbol for division. If I change this division to multiplication now, I have 150 times, this will go up, this one come down, 4 over 15. This one here, 1. This one here is 10. So 10 times 4 will give me 40 Newton. My effort is 40 Newton. My effort is equals to 40 Newton. Effort is 40 Newton. Okay? That's option B. Option B. So when I made use of that formula, efficiency is mechanical advantage of velocity ratio times 100. So I solved, and then these are the steps. That is the efficiency, which is 75 over 100. Now when I cross multiply this with times this one times this one, that's 100 times MA equals to 5 times 75. Okay, so making MA subject to formula, divide by the coefficient. MA now will be 5 times 75 divided by what? 100. So that is it. Okay, then you see that 5 go here, 5 into 100 is 20. That's 75 over 20. Okay, when I still divide again, I'll have 15 over 4. Now reduce to the lowest term, that's mechanical advantage 15 over 4. Now mechanical advantage is also the load over effort. When I interchange position, this one can go here, this one come here. To make E subject of formula, what I did is to make effort subject of formula. So just interchange their positions. That is effort to be equals to load over mechanical advantage. You interchange position, this will come here, this one will go here. So put the value of the load. The load is 150 Newton. If you observe, load is 150 Newton. So put it there, over mechanical advantage is 15 over 4. You have this. Now that will be 150. This line is symbol for division, divided by 15 over 4. If I change division to multiplication, I'll have to invert this. This will go up, this will come down. That is times 4 over 15. Then finally, I'll be having what? 40 Newton. Alright? That is it. I'm having 40 Newton. So 15 going into 15 is 1. 15 into 150 is 10. 10 times 4 is 40. That's the effort. The effort is 40 Newton. Alright. Alright, we have another question on the board. It says a load of mass 120 kg is raised vertically to a height of 2 meters in 30 seconds by a machine whose efficiency is 100%. Calculate the power generated by the machine. Now we'll list out the parameters given to us. First thing that was given to us is the load and the mass of that load. The load L, we'll obtain it. We know that it is mass times acceleration due to gravity, which is the mass is 120 kilogram. Okay, that's 120 kilogram times G is 10 meters per second square. Okay, so this now is 1200 Newton. That's the load. Is raised vertically through a height of 2 meters. So distance moved by load small l is equals to 2 meters. Alright, in 30 seconds. So the time taken, time t is 30 seconds by a machine whose efficiency is 100%. So the efficiency of the machine is 100%. Okay, calculate the power generated by the machine. Power generated by the machine the power generated by the machine is equal to the power output of the machine Okay, so we'll write out the formula for efficiency. Efficiency is equals to power output over power input times 100 measured in percentage. Okay, that's efficiency. the power output over power input times 100. All right, so we continue. Now, the power output is the power generated by the machine. Okay, so it means the efficiency is equals to P out over P in times 100. Okay. All right. However, we are told that the efficiency is 100%. So if I put this value now into that formula, this is the formula we're using. Put the value there. We're having a. Now the efficiency was given to us as 100%. Converting 100% to fraction, that is 100 over 100, is equals to P output over P input. All right. So we know that 100 divided by 100 is 1. Is equals to P out over P in. So when I cross multiply, I'll be having my output power is equals to the input power. Okay, that is power output is equals to power input. Okay, so if the efficiency is 100, that means if it's 100%, that means 100 divided by 100 is 1. And that means that my power output will be equals to power input when I cross multiply. Okay, this times this, and I'll be having this linear equation P output equals to P input. Now remember that my power output is equal to the work done by machine over time. Okay, and the work done by machine is equals to the load times distance moved by load over time. All right, so my P output now will be equals to load times distance moved by load over my time t. So P output is equals to the load there. We solved and we obtained the load as 1200 Newton and the time as 30 seconds. Okay, and distance moved by load is 2 meters. Right, it's right there on the board. Distance moved by load is 2 meters. So this now will be 1200 multiplied by 2 divided by the time is 30 seconds. Okay, so this now will give me 0 can cancel 0. 120 times 2 now is 240 divided by 3, and 240 divided by 3 will be that will be 80 watts. Okay, so the power output is 80 watts. So when I divide this 240 divided by 3, I'll have this 80 watts. Okay, so therefore the power generated by the machine is equals to 80 watts, because initially I stated that the power generated by the machine is equals to the power output of the machine. Okay, the power output of the machine is equivalent to the power generated by the machine. So power generated by machine is the same as the power output. Okay, so when we finally solved, we saw that efficiency is 100%. 100 divided by 100 gave us 1. So P output will be equals to P input, and the power output is work done by machine over time. The work done by the machine is load times distance moved by load divided by time. The load is capital L, distance moved by load small l over t. The load there is 1200 Newton. The distance moved by load is 2 meters. While the time is 30 seconds. So by substitution, I'll have this. Now what will happen now? Divide 0 cancel 0. 120 times 2 is 240. Divided by 3, I have 80. That is 80 watts. Okay, 80 watts. Okay, we have another question on the board. It says a machine whose efficiency is 75% is used to lift a load of 1000 Newton. Calculate the effort put into the machine if it has a velocity ratio of 4. So let's list out the parameters in that question. First, we look at the efficiency of the machine. The efficiency is 75%. Okay, is used to lift a load of 1000 Newton. The load is 1000 Newton. Okay, now calculate the effort put into the machine. The effort put into the machine, you can say effort E is unknown. If it has a velocity ratio of 4, velocity ratio is equals to 4. Okay, and we know that efficiency is mechanical advantage over velocity ratio times 100. Alright, now we come back to the efficiency given to us, which is 75%. Converting that to fraction is 75 by 100. 75 divided by 100 is equals to mechanical advantage is unknown divided by the velocity ratio, which is 4. Okay, so I can then cross multiply. That is 100 times mechanical advantage is equals to 4 times 75. So this will multiply this will multiply this. If I divide by the coefficient of MA, the coefficient of MA is 100. So dividing by its coefficient, I'll be having MA is equals to 4 times 75 divided by 100. 4 here, 4 into 100 is 25. Okay, so my mechanical advantage now will be 75 divided by 25. 5 into 25 is 5. 5 going to 75 will give me 1 remainder 2. Yeah, 2 into 25, that's 15. 5 here, 1. 5 into 15 is 3. So my mechanical advantage is equals to, say therefore mechanical advantage is 3. That's my mechanical advantage. Alright, so that is it. 5 into 25 is 5. 5 into 75 is 15. 5 into 5, 1. 5 into 15 is 3. So my mechanical advantage is 3. So we are not done. We'll still continue. Now recall that mechanical advantage is equals to load over effort. And we are asked to look for the effort. So I can then interchange position. Effort will be equals to load over mechanical advantage. Now I've made effort the subject of formula. By making effort subject of formula, I will interchange the position. This will go here, this one will come down. So I'm having that E is equals to load over mechanical advantage. So my effort now will be equals to, put the value of the load. The load is given to us as 1000 Newton. 1000 divided by the mechanical advantage is 3. So when I divide 1000 by 3, I'll be having 333.33 Newton. Okay. Alright, that's the effort, 333.33 Newton. Okay, so just observe what we did. Observe the steps we took again. How we listed out the parameters. Then we wrote the formula for efficiency, MA over VRU times 100. Then we made MA subject of formula. And we had the mechanical advantage as 3. And then we continued over here. MA is load over effort, making effort subject of formula. Finally, we have effort is 1000 divided by 3, which is 333.33 newtons. Okay, let's move over to the next question quickly. Alright, we have another question on the board. It says the efficiency of a machine is 60%. Find in joules the work done by a student using this machine to raise a load of 150 kg through a vertical distance of 2.5 meters. Alright, so quickly let's look at that. We'll first list out the parameters. The first one is the efficiency of the system. The efficiency was given to us as 60%. That's the efficiency. Was given as 60%. It says find in joules the work done by a student using this machine to raise a load of 150 kg. The load is 150 kg. But we can't leave it like this. We have to convert it to SI units. That's L is equals to mg. Convert it to newtons. Convert to newtons. That is 150 kg mass multiplied by 10 meters per second square. That will give us a load of 1500 newtons. Okay. Then we are also told that it moves through a vertical distance of 2.5 meters. Okay, so distance moved by load. Distance moved by load. Distance moved by load. Small l is 2.5 meters. 2.5 meters. Okay. So find in joules the work done by a student using this machine. So work done by students using machine is equals to the work put into machine. Okay, so the work done by students using the machine is equivalent to the work put into the machine. All right, so let's go back to the third formula I gave you for efficiency quickly. Let's look at the third formula for efficiency. The formula is efficiency equals to work done by machine over work put into machine times 100. Okay, now the efficiency was given to us as 60%, which is hold on a bit. So efficiency, work done by machine is load times distance moved by load over work put into machine times 100. Okay, so at this point now we can then solve the problem. Okay, so we can solve the problem now, and I'll be having efficiency is 60%, that's 60 over 100 is equals to the load. We solved and we got the load as 1500. Distance moved by load is 2.5 meters. Okay, that's 2.5 divided by work put into machine. So there will be no need to make use of this 100 since we have already converted the percentage to fraction. That is it. We converted 60% to fraction. That is 60 over 100. Now, I can cross multiply. I can cross multiply this times this times this. That will be 60 times work put into machine equals to 100 times 1500 times 2.5. Okay, so that is this times the whole of this. Now the work put into machine will be 100 times 1500 times 2.5 divided by 60. That's when I divide by the coefficient of work put into machine is 60. So when I divide by 60, I'll have that. So that means that the work put into machine will be equals to, when I multiply the whole of this, I can say 0, we cancel one of this, 0. And I'll have, when I multiply it now, I'll be having, multiply the numerator, I'll have, okay, this will give me 37,500 divided by 6. That will be, if I divide by 6, I'll have, this will give me 6250 joules. Okay, so that's the final answer. Now, if you recall vividly, we are told to find the work done by student using this machine, and I say the work done by the student using the machine is equals to the work put into the machine, right? So I say therefore the work done by students using the machine is 6250 joules. Alright, so that is the work done by students using this machine, 6250 joules. Okay, so that's everything that we have solved there. So what we have solved in that question number 5. Question number 6 rather. Question number 6. Alright, we have another question on the board. It says, what do you understand by the statement the force ratio of a machine is 5 and its velocity ratio is 8. The force ratio of a machine is 5 and its velocity ratio is 8. He said this means that the load moved is 5 times the effort applied. And the distance moved by effort is 8 times the distance moved by load. At the same time interval. Okay, so this means that the load moved is 5 times the effort applied, and the distance moved by effort is 8 times the distance moved by load at the same time interval. Now remember that force ratio is same thing as as mechanical advantage. Okay, and mechanical advantage is load over effort. So if the force ratio or the mechanical advantage is 5, if it is 5, it means that what the load moved is 5 times the effort applied. Okay, so the load moved is 5 times effort applied. That is the meaning. That is, load is 5 times effort. That's the meaning of that statement. This happens when your mechanical advantage is equals to what? 5. And also, we also stated that velocity ratio is distance moved by effort over distance moved by load. So that statement, now if the velocity ratio is 8, it means that the distance moved by effort is 8 times the distance moved by load. Okay, so distance moved by effort is 8 times the distance moved by load. So therefore, the velocity ratio will be equals to 8. Okay, so it means that distance moved by effort is 8 times distance moved by load. That means that velocity ratio is 8. Alright, so we'll stop there. That is the meaning of that statement. It says, what do you understand by the statement? The force ratio of a machine is 5 and its velocity ratio is 8. So this means that the load moved is 5 times the effort applied, and the distance moved by effort is 8 times the distance moved by load at the same time interval. So mathematically, the force ratio is same as mechanical advantage, which is load over effort. Now the load there is 5 times the effort, which means that is the mechanical advantage. So mechanical advantage is 5 if and only if the load is 5 times the effort. And velocity ratio is 8 if and only if the distance moved by effort is 8 times the distance moved by load. Alright, we'll stop there for now. Thank you very much. Thank you.